Okay, so here we go. We're beginning part 2 of lesson 5. So while cruising along a dark stretch of highway with the cruise control set at 25 meters per second, you see at the fringe of a headlight that a bridge has been washed out. Wah, wah, wah. You apply the brakes and come to a stop in 4 seconds. Assume the clock starts at the instant you hit the brakes. So let's go ahead and do a review what we've already done. Notice it says qualitative there. So let's do a review of what our graphs look like. So you got x versus t here. And if you're going in the positive direction, you curve like that. Your velocity versus t, put a 0 down here. If you got an a versus t like this, if this is 0, it's just a positive, or actually it's negative. We'll put our 0 in a different spot. We'll put our 0 here, and the value of this car is in the negative direction, A versus T. Again, that's our review. Now, we're going to go ahead and construct a quantitatively accurate V versus T graph. When you're solving these problems, you're going to use your graphs. So, and we'll also use the equation as well. So you're going 25 meters per second. And you come to a stop in 4.0 seconds. So it's 25 to a stop, which is 0 in 4 seconds. So let's go ahead and look at this. We'll go 5. So we got V versus T. 5, 10, 15, 20. So 25, 1, 2, 3, 4 seconds. So we'll go approximately like that. All right, so on V versus T graph, graphically represent the car's displacement during braking. Okay, and then use it to determine how far it traveled. Okay, so on this graph, here's how far it traveled. So we just got to find that area. So the area then is equal to 1/2 base times height. So that's equal to 1/2 times 4 times 25 meters per second. So that gives me 50 meters. So that should go here. So 50 meters. All right. So now, in order to draw an A versus T graph, you need to determine the car's acceleration. So to do that, we just look at the graph and find the slope. So what's that slope? And then again, this is a review, but it's still good to try it. So it is going down and over. So it's going negative 25 meters per second in 4 seconds. And that gets me a value of negative 6.25 meters per second squared. All right, so that's how we can use our graph to solve these problems. Right, and if we want to draw quantitatively accurate, you go 0 across here. It'd be negative 6.25 across the bottom here like that. All right, now let's use the displacement. Let's use our formulas to find the displacement and the acceleration. Okay, so we're asking for delta x. We're looking for, we have V final, which is 0. V initial, which is 25. And we have a time of 4 seconds. Again, I got that from the reading. Now here comes the hard part. It's like a puzzle. Is you got to find one of these equations, use one of these equations that has V final, V initial, delta x, and t. We've got delta V. Oh, we don't have that. We don't want to use that equation. Oh, delta x we have. V final have, VI we have. Or we're trying to find delta x. That's our question mark. And we have t. So we want to go with the second equation here to solve this. Oops. So we have delta x is equal to v final plus v initial, 1/2 times our t there. So that's 1/2 times 0 plus 25 times 4. And that's going to get us the same value as we had before of 50 meters. As a bonus for this lesson, I can show you how the equations define acceleration. So now we have a delta x equal to 50. We just solved that. We're trying to find a. So we got a lot more information now. We got 1, 2, 3, 4 pieces of information. So if we look at our equations, we have, we could use this. We have delta v. We have t. Trying to find a. We could use equation 1. We wouldn't use equation 2 because it doesn't have a. The other equation we could use is this one because we have delta x now, vi, t, and t. So we could use equation 3, or we could use equation 4. And we're solving for that. However, I'm just going to go ahead and stick with the first equation here and solve for that. So let me go back. So we have delta v is equal to a times t. So delta v would be 0 minus 25 equals a times 4 seconds. So you end up with negative 25 divided by 4 gives us a, and that gets us the exact same answer. So that's one of the tricky things when we go to do this example, these problems tomorrow in class, is there's going to be multiple ways to get to the same thing. And a lot of students don't like that. So this sheet here, right here, is like your lifesaver. It gives you so much info. It's so good because it's just like your quick reference guide right here. So anyway, come tomorrow. We'll probably do another example problem in class, and we'll try that worksheet during class. Hey, have a great night, and see you tomorrow.